I would talk a little bit about our journey and what we've done with automation in general, and some zero-touch efforts, looking more at some of the early stuff we've done and some of the things that kind of got us or that you might want to pay attention to. And just to put it in perspective, right? What we started off with is, I don't know if anybody knows about PCCW Global, but we're your basic carrier. We have a fiber network. On top of that is our IP layer. And on top of that, we run some voice services. And then we have a stack of traditional value-added services that you would expect a carrier to have. UCaaS, mobility, security, all those things. And so, see if that button worked. Nope. There it is. All right. So here's our fiber network. It's maybe not the biggest network, but it's one of the more diverse networks, we think. We have some capacity on pretty much every cable system that exists that's of value, right? And then, of course, our IP backbone sort of really looks similar to that footprint. We're a fully peered IP network, with more or less about 100 POPs in a bunch of different countries. And so it's big enough, it was sort of small enough back a few years ago that doing everything manually kind of worked, right? There was complexity in maintaining the diversity, but it was still manageable. But then as the traffic's increased and as what customers are expecting is increased, we started kind of running into some situations, and so we started breaking things down. How do we automate? Where do we automate? And so we basically had these 4 areas that we figured we needed to do some form of automation on to make things easier, more manageable, and to simplify the engagement with customers and to speed that up and make that a little bit more agile. And basically it's services, infrastructure, operations, and then the whole end-to-end resource management. And the theory we had is that we'd come with a fully automated provisioning system, and everything kind of gets provisioned and deployed with a bare amount of human intervention. And what we found out is that you're not going to get rid of the human intervention, right? At this point in time, you're still going to have some human intervention because there's always going to be exceptions that just can't be abstracted or taken care of. And the full automation is really expensive, right? When we were talking to people early on, they're like, yeah, we can do all that for you, but it's $35 million, over several years. And we're like, well, we wanted to do something quick now that was sort of cheap. And then the other issue that with full automation is as you put things into an automated fashion on a server, on software, you've now expanded your attack surface, right? It's because of the complexity of software stacks, it's a little bit harder to manage all that. So you're making your network maybe a little bit more insecure. So rushing for automation might not be the best approach. So we sort of figured we would just do what we could as we could, with what we had available that made sense based on what our customers were really asking for, what our customers were having problems with. And we figured, okay, if we automate something, right, that's wonderful. So we take something that used to take 90 days, and now we can do it in 89 days. That really wasn't going to help our customers very much. And back, in the 2010, 2011-ish time frame, again, we were still doing okay manually provisioning things. We had automation in there already, but it wasn't a big push. So what we started worrying about were all the stealth operations, all the processes being managed in email that were being tracked on spreadsheets. And because we realized that data is probably going to be a big important thing for automation, so we got to get the data out of the emails and out of the spreadsheets and off the desktops into a central system. So we started building modules to take care of all those things. We realized inventory was going to be critically important for anything we did. Shipping is another thing that you may not necessarily think about, but you burn a lot of time in shipping, and import-export compliance is a big deal, right? That can cause all kinds of troubles for your business, so we wanted to sort of get a handle on that. Transfers of equipment, either to customers or between business units within the company. Returning bad gear, again, which is more of a shipping and an inventory tracking thing. Tracking leases, so we know where equipment is, how do we get it, things like that. People's time, remote hands, all those things we needed interfaces for in preparation to automate those things so that we can actually zero touch shipping equipment, right? So that the time someone asks for something, someone has the idea, right? You can take that, feed that into a system, and then just push it all the way through project management, all the way through to deployment to get it to the point where it needs to be configured in an automated fashion. So we were looking end to end, sort of, that's where we started from, really. That was the main thrust, right? Is how do you keep all these projects, all these things moving with minimal human intervention so that they don't get messed up, so that your data doesn't get corrupt from the get-go, all right? Then the next thing we focused on as far as automation was the data center itself, because, you know, a tremendous amount of work has been done in that area. And so we looked at a bunch of different things, and we tried a bunch of different things. And ultimately what we settled on was a canonical open stack using Juju and Moss, right? To, you know, you rack a server, Moss brings it in, Juju compare, you know. So we took building a data center probably from a week or so, once the network was in place, to put in the service, took about a week or so to stand up an OpenStack, to about 40 minutes. And we figured if we're going to be throwing, you know, data centers around the network, 100 some odd sites, it would probably behoove us to have a way to push those out quickly and easily and cleanly, and then more importantly, have a way to upgrade them and update them and patch them going forward. And Juju worked out pretty well for that. And we still use Heat and other orchestrations on top of OpenStack for applications and whatnot, but the OpenStack core itself, we use Juju for that, and it works out quite well. So then, you know, we figured, okay, well, now we've kind of got some things moving there. We decided we'd want to take on the actual, you know, some automated configuring of services and devices. And so this is sort of the flow of one of our earlier efforts. You know, the technologies have basically stayed the same. Some of the ideas have changed, but it starts off with, you know, a user, a human, either through some sort of web app or by writing a text file. That text file gets pushed into our code repository system, which we use Bitbucket. Then some CI/CD process sort of checks that when it's, oh, something new came into Bitbucket. It would check it out, and it would run it, you know, put it into oxidized for revision control, and then down on the end, it would push it, basically model the change, right? And we're not talking any, you know, extensive modeling at this point in time, but just doing some sanity checks, make sure gravity's working, you know, that nothing's going to get, you know, irreparably damaged, and that all policies and procedures are followed. So we do that little bit of modeling. If it's good to go, then we pushed it into Salt Stack and push out config, right? If it's not good to go, then we come back and let the human know that we're not going to deploy this. This isn't going to happen, right? And so, you know, Bamboo would take stuff, and it would you know, basically stick stuff. It would pull data out of a MongoDB database because it needs to get IP and other information programmatically, because we support parameters in the configs. And then ultimately, when it goes to do the change, it would push it in a Jira ticket, right, and let a human know, you know, via hip chat, throw it in a channel. And that's sort of what we worked. And so the things that really, you know, that we really kind of focused on was the testing piece, the modeling, right? Because the more you automate changes, the more things you're automating, the more likely you're going to have parallel changes that conflict. Or, you know, someone's going to change something, they're not going to have a good understanding of how that butterfly effect is going to affect something else. Maybe a customer's got an SLA guarantee, and you're about to torch that, right? So the testing becomes a big thing, but you can't manually test everything. And so that's why we felt modeling, and that modeling piece is really where machine learning is going to eventually shine, because again, you're not going to be able to manually code every test, every policy. So you're going to have to depend upon machine learning through watching a long time period of changes to build a knowledge model that says, you know, that can detect this change might cause you some problems, right? And machine learning is a data that is probably not any specific machine learning model. You're probably going to have to rely upon a few different models to push that through. But that's one place where we're working on, you know, trying to get a handle on machine learning as it applies to testing changes. So that covers the modeling and the modularity, right? The other thing we realized is old school networks were built to be understood by humans. That made it very difficult to automate, because humans like, they have personalities, and so they tend to do different things different ways, but you get to the same result. What you really need is a repeatable design, simplified, modular, that may not be the most cost-effective at a small scale, but as you're scaling up and, more importantly, scaling out, it makes it much more economical and makes it actually possible to scale out. Because, again, old school networks, we were sort of more of a scale-up model. Router gets full, you put in a bigger, you just add another card, right? You keep adding cards, and then we have, oh, look, a multi-chassis. We'll put a chassis next to the existing chassis, bond them together, now we got a big chassis. So we'd scale up, but that's kind of labor intensive, and it's really hard to automate and hard to make that happen in a seamless sort of way. Somebody's gonna, you have more risk of downtime because you're touching something that's already working. Even though you're just adding something, you can still, we fried power supplies, both of them, because the card we inserted had a little bend in the clip and it just shunted both power supplies. Whole router went down. So it's better to take more, maybe a scale out and just spin up new ones right next to them and just stack them out, and then when you don't need them, you pull them back, right? Modularity makes that happen. There's a couple of laws that sort of guide my actions and my thinking on these things. And first is Ashby's law. Ashby's law says only variety can consume variety. Another way to say that is complex problems have complex solutions. When you have a complex problem, you say, oh, look, a simple solution, it's not going to work, right? You're wrong. So you got to rethink. You got to be prepared for complex solutions. There is no silver bullet, right? Gall's law is kind of a corollary to that says good complex solutions evolve from good simple solutions, right? So you want to solve a complex problem, you have to solve a simple problem first, and you have to solve it well first, and then you kind of scale up from that and build your knowledge. In the Marine Corps, we would say something over and over again, the expression, slow is smooth, smooth is fast. How can you do something that's complex and hard fast if you can't do something simple smoothly? You can't. So those were sort of the big takeaways for resource configuration. And so, kind of piling on to that, the thing that made it hard was there's no modularity and there's no abstractions in the control plane itself. So every time you have a new control plane problem you want to solve, you kind of got to build the whole thing from soup to nuts, ground up, because we don't have the same types of abstractions that exist in the data plane. So to build a web app, it's real easy because I can build an email application without having to put bits on a wire. With control plane, it's not the case. You have to know topology, you got to know where things are, you got to know what state they're in, and those abstractions just didn't exist, and that's the whole reason SDN came about to begin with, not really to separate control plane and data plane, but simply to provide abstractions to the control plane itself. Barbara Liskoff, you may or may not know who she is, she invented object-oriented programming, Turing Award winner, and she said that modularity based on abstractions is how things get done, period. And that works for software and it works for networks, right? And so it just reinforces the concept that we have to put these modular abstractions into place, right? And so that we get this model where you have a big ball of mud where everything's just kind of slammed in there, right? To more of a proper abstraction so that we can process topology, we can we can comprehend that, we can share it, we can distribute it, and so lots of different applications can then drive the network without having to really know the details. So you can start treating networks like their software with transactional changes. So you can mess something up, you can roll it back easily. You can make frequent releases, right? You can actually decouple deployment from releases of features in the network, and more importantly, you make topology a lot simpler. All right. So this is sort of our view of network architecture, of how we're coming. This slide actually had animations that made it kind of like cool, but it's distracting too. So on the bottom where we have our transmission network, then on top of that you have the IP network. The IP network, connects to the transmission network, and it's not single homed like that really. It's actually multi-homed with no single points of failure. And then on the edge, we have these edge islands, right, of basically like 3 3 and 5 stage cost networks, right, that are all SDN controlled. And then we connect those edge islands over the IP network via different, I hate to use the word slice, but different types of overlay connectivities, be it MPLS, VPNs, SD-WANs. And then we have our services that kind of cut vertically up and down. So the horizontal things have 3 basic abstractions: ports, connections, and services. That's really the horizontals are really ports and connections, and the services are the vertical piece. And so all these things support some type of interface, installation, configuration, connections, upgrades, updates, scale out, scale back, health checks. And so these are some of the operations that we're trying to put into the into the abstractions, into the software that's driving the automations. So one of the other things that we felt we needed to do is manage data flow, right? Data is not static. It doesn't sit in one place in a big monolithic database anymore. It's more about data movement is the important thing. So me personally, I'm less concerned about data structure and what columns and you have and is it a varchar or char 255. I could really care less about those things. I care more about the actual movement of data and how we can maybe normalize that data so that we can put it somewhere so that we can eventually push it through some machine learning so that we can share that data across a wide number of people in a way that it's easy to be driven. And so, some of the technologies have changed since then. We still use Cassandra, but maybe HBase would be better. But again, I don't get too caught up on the piece of technology because for the most part, anything can work. It's a matter of scale typically where things start breaking. And so then you got to be able to replace it. We use Druid as a database because it's really handy for managing NetFlow type data. It's very fast and efficient. And so the basic idea is you have a bunch of different collectors running. And we're looking maybe at layering NiFi into this, the Apache NiFi project, to kind of move data because it has a lot of governance features so you can track where data came from, how it got moved, how it got manipulated. But these polars come in, push their data onto a big Kafka bus, and that gets pushed through Spark, right, where you have the machine learning engine in Spark. And then we, can push that out via APIs. There's a set of real-time APIs for things like enriching faults, performance management, tweaking network configs on the fly. And then there's the deep query stuff, right, for billing, longer-term analytics, business intelligence type stuff. And then, as far as the operations piece, then we take that data that's everything's being collected through our open data platform, and we're going to merge that maybe in with some other data sources, either maybe from customers or whatnot, into a framework that we just plug modules in and ultimately have some user interface. So operations has a single pane of glass to understand everything that's sort of somewhat driven by machine learning to let them know certain events that may be more relevant than others, because when you start putting cloud networks and a bunch of other things together, it gets really noisy really fast. One of our security applications is a big machine learning application that does threat detection, and we're taking that technology and working to apply it to network events as well. And the other thing we realized is that we didn't have one business, we had 3 businesses, right? And so you have, at the bottom, the Horizon 1 business, which is the core business. It's the thing that's making money today. It's our cash flow today. And what that business is mainly interested in is process innovation. You're not going to be able to take some innovative idea or product and just shove that in because the operations and all the other support around it really isn't tuned to support that. You're going to create a lot of organizational debt and a lot of troubles and difficulties moving that actually into production. So those types of things are actually better served by a different group, a Horizon 2 group, maybe that's more focused on emerging businesses, rapid growth businesses, and it's more of a business model innovation, taking your products and sort of maybe evolving and changing those, because as you automate and now you're making things more machine consumable, it's a perfect opportunity to look at products and how you build products and how you engage customers in consuming those products and sort of fundamentally changing how the products are based, right? There's lots of opportunities there to generate growth tomorrow. and that's more of a 2 and 3 year horizon for true revenue recognition, whereas the core is the Horizon 1 is today, and then you have the Horizon 3, which is all your disruptive, your R&D efforts. And then you got to have a process to take things from that unknown area and move those down the waterfall there into a known area where your operations is. And it sort of becomes incumbent upon the Horizon 1 to be able to embrace those and work to move those in so that they're not so resistant to the change, because ultimately you have to change. And this is just another way sort of to look at it, right? Is the tools and the processes and the technologies used by each of these horizons is probably a little bit different. And so you really can't have one group sort of focused on all of these. And so within PCCW Global, we've sort of spun off a new group called Technology, for lack of a better term, I guess. And that's mainly what that group does, is it sort of works on. We also support the mature business, right? But the mature business doesn't need a lot of work, right? Because it's mature. And so there in the mature business, we're mainly, again, innovating on process. We're tweaking processes, making small improvements, taking existing products and making them a little bit better. But we're not really radically redefining the company because, again, it's too disruptive. We can't continue to make money and innovate at the same time. So you'll have some companies that take care of that via Skunk Works. I think Skunk Works are very negative things for companies because that means the company itself doesn't value innovation, so groups feel they have to be clandestine and innovate under the dark of night, right? Now, I know, Kelly Johnson did a great job, at doing it, but that's an exception. NASA did a great job of putting something on the moon, and that's also an exception. We can't do that every time using a waterfall, right? So you have to kind of make the whole company embrace a culture of innovation, and that's a hard thing to do. And so what we've found is it's better sort of to compartmentalize things according to these 3 horizons, and it makes it a little bit easier to honor innovation and have it get ingested into the business itself. Speaking of the technology group that formed, we made an acquisition, a company in Australia called Console Connect. They had a different business model. Very similar to what we did, they just did it different. They had different terms and they packaged and engaged with the customers differently, but it's a full automated provision, and we just deployed this live to some 30 sites. The other 70 or whatever come in short order. And in the process of bringing this and integrating this in and sort of spinning up that Horizon 2 business, trust and culture kind of became a big thing. You got to get the operations people to trust the automation. If they don't trust the automation, then they're going to break the whole thing. Anybody's familiar with 3 Mile Island, that's kind of what happened. Is the automation was working to protect the nuclear power plant, but the operators didn't trust it, so they tried to intervene manually, and they ended up melting down the core. You got to get the people to trust the automation. The other thing we learned is that dirty data will kill you. Before Console, we tried to do something like this on our own, and we figured out it would take like about 280 years. It was 10 days per customer, then 1 day per site to clean data. So it was like 280 years. We maybe thought we could optimize it with automation, maybe get it down to 120 years. So we figured maybe that wasn't the best approach, and that's why we kind of did, a different model and sort of spun up that little Horizon 2 business through Console. And again, it's don't just try to automate the manual tasks because those were optimized for humans to follow, and they're probably full of errors. It's better to sort of just rethink your products and rethink what you're doing and come at it with the fresh, new set of thoughts, because it's a nonlinear problem. You automate something today, it changes a whole bunch of possibilities. It's not a straight line. Now a whole bunch of other things are possible, and people start to realize that, they change their behavior, which is what Jevons paradox is. Jevons paradox is actually from economics. It says the easier it is to consume something, the faster it gets consumed. So as you start adding automation, it changes everything within the company. And then lastly, the sort of how we manage this is we use something called the scale. We're adopting scaled agile framework. We already were doing parts of this. We kind of had invented and discovered on our own, and then we realized that there was this whole framework that's like took everything we were doing and made it better. And so we've been working to get our people certified and trained on the scaled agile framework. And the key thing about it is it focuses on quality and, more importantly, transparency. It gets a whole bunch of different groups working in the sync and cadence on one heartbeat together, so that you don't have people running off and doing things on their own, because it empowers the actual staff themselves to make decisions. It doesn't centralize decision making. It pushes that down to the people doing the work. I believe it was, maybe it was Warren Buffett or Pete Drucker, somebody said, knowledge workers are workers who know more than their boss about their tasks. So manual workers, you know, the bricklayers, the boss knows how to lay bricks better than anybody. In knowledge working field, network engineering, automation, these things, I don't know anything about this. My guys know anything about it. They're the ones who really should be making the decisions. So you have to empower them through intrinsic motivation, right, to let them do that. And we found the Scaled Agile framework was a very good model for that. And my time is red, and that was my last slide. So if you have any questions, feel free to ask. I'll be around.
Great.